Okay, well, I'm going to get started. So those of you on Zoom, I might be asking you questions and asking you to like raise your hand if or not. So please do that if you can. If I ask you to raise your hand and you're in person, obviously you just raise your hand. You don't have to click on the little emoji thing. Yeah, so my name is Janice McCarthy. I'm faculty here in the Biostatistics and Bioinformatics department. And I am here to teach you introductory R. So I want to just let you know, we had actually changed the ordering of things because usually you get Josh Granick's lovingly called, lovingly referred to as his reproducibility rant that he gives for these workshops, and it's about reproducible research, but also about Git and GitLab and GitHub and stuff. And so you would have had that and you would have known how to clone the repository, but now I have to show you how to do it because we changed the order. So we're going to do that first. And I guess the first thing I want to ask is, how many of you have used GitHub or GitLab or some version of that remote repository kind of stuff? Okay, so a couple of people here. On Zoom, how many have you used GitLab or GitHub or any of the versions of Git? You can use your little icon, the hand raise thing. And do you see those, Richard? Because I don't see them here. Okay. Oh, I guess if I just click on participants here, I should be better at this by now. But yeah, okay. So some people do, but some people don't. So very briefly, and you're going to learn a lot more about this in the next lecture, but I'm just going to give you an overview now so that you're not completely lost, those of you who've never used it. Git is a version control software, so it allows you to keep track of changes you've made to your code, and then you can back up if you decide that, oh, I've introduced a bug and I want to go back to the version before I introduce the bug and figure out what happened. That's one use for it. And it's also a collaborative tool because you can have places like GitHub or GitLab. These are hosting repositories. So your code is out there in the cloud, and any of you and any of your collaborators can access it from any machine that's using Git. And so, and you can clone a copy to your computer and push and pull to make updates. And if your collaborators have made updates, it will try to merge versions. So as long as you both haven't changed the same exact thing, it will do a merge, and so you don't have to worry about the fact that somebody else is also coding. So it's a great collaborative tool. It's actually developed by Linus, the father of Linux. That's basically what they used as version control to develop the Linux kernel. So we are going to go to this URL up here. So you are all sent an email to make sure that you could get onto the GCC on demand. This little file here is in our repository. So this HIV R25 224 225 content, that is a GitLab repository on Duke's GitLab. So if you go up here to the URL, you can see that it's GitLab OIT, HIV R25, and so on. So what I want you to do now is I want you to get this address into your clipboard. Not the whole thing, though. Yes.
To the homepage on Weebly, there is a short URL and a QR code for the people in the room.
Oh, okay. To get to the repo. Oh, I didn't know that. Okay. So go back to the main page.
So
I don't.
We have a QR code there.
Perfect. Okay. So yes. So for people at home, there's a link to the repo in the chat. And for people here, you can just use that QR code. Very nice, Richard. Thank you. So that QR code will give you the URL to pull up basically the main page here.
Yeah. And I think it's duke.is, and then I think it's R245-
yeah.
2024-2025-.
Yeah, you can see the URL here. But actually, if you're already there and you click back home, you could be here too. But anyway, somehow I need you to get this address that is here. I need you to get this address, which is the gitlab.oit.duke.edu/HIVR25/2024-2025 HIV workshop. So I need you to copy that, leave it in your clipboard. And don't copy anything until so don't overwrite that, basically. So now what I want you to do is go to the DCC on demand. Okay, and we're gonna start up our studio containers. So I'm gonna walk through that. I'm gonna try and go slowly. Please speak up if you are lost or I am going too fast. Please, if you're on Zoom, feel free to yell at me. I mean, you can put something in the chat and Richard will carrot, but I don't care. If you just say, hey, Janice, wait, I didn't get where you are, that's fine. I expect that, okay? So I'm gonna go to DCC On Demand, the home page here. And I'm already logged in because I'm I'm already logged in. So you might have a login screen where you have to put in your net ID and password, but you have presumably already done that. Okay, we go to interactive apps. We pull up the CHSI RStudio workshop. And then we don't change anything here. Wall time, 4 hours, that's good. CPUs, 2 is fine for what we're doing. Memory, 2 gigabytes, that should be fine. No GPUs. And then here in the account, mine says 2023. So make sure it says 2024. So HIV-R25-2024. And then the partitions should be CHSI high. And then your image is R25 HIV/AIDS workshop. And now we're just going to click the blue launch button. Good. And now we're all trying to do it at once, so it's going to take a few minutes probably to get the little blue connect button. Okay, mine's here. Okay, so once that comes up, we can connect to the RStudio server. And we get this lovely instance of RStudio. How many people are very familiar with RStudio? Couple. How about on Zoom? Familiarity with RStudio. Okay, so lots of hands not up. Okay, don't forget to bring your hands back down after you ask questions. Otherwise, I'll get erroneous results. Okay, so RStudio is a graphical user interface, or a GUI for R. So if you were to just like go into your operating system and run R, you would only get this console thing here, right? It would be like a text interactive. So what RStudio does is it gives you this graphical interface so that you can type in here. But we can also, and this is what we're going to be doing, we're going to be making files. So we're typing our code into files, specifically R Markdown files, and saving them. And so that's how we're going to run our code. But we'll start out today a little bit just playing in the console, just to do a couple of silly things before we move on to the Markdown notebook. Okay, so now I'm in RStudio. Is everybody where I'm at? Is there anybody who is not at this point? And if so, yell or put something in the chat. Oh, wait a minute. Yeah, they look good. You can tell. There are facial expressions that give it away. Okay, so all right, so great. So we're here, and now what we're going to do is we're going to start an R project. And for those of you who don't know what RStudio is, you definitely don't know what our projects are. But it's basically sort of a self-contained system for your R, like a whole project. So you might have multiple files and things like that of different codes that all relate to a single project. And so that's when you would use this. You also use it for sure if you're doing, if you're writing an R package. Okay, so we are going to go to the file menu, drop down, and create a new project. So when I have to, you guys stay right here. We're gonna create a new project. Don't follow me. I have something I have to do. Because in order for me to do this, I have to remove my Okay, excellent. All right, so now I'm going back to the console. All right, file menu, and then we're going to create a new project. And now it gives you options. You could start a new directory. You could use an existing directory. Say if you started writing some R code, putting in a directory, and you have multiple files, and now you're like, okay, I want to start a project now. You can do that, but we're going to do version control because this is the interface with Git. So this is how we're going to get, so you're on your RStudio server in Duke's Cloud, right? And you have a file space in there, right? We are going to clone the course repo into your file space. Okay. So we'll click on version control, and we're going to say clone from a Git repository. And for the URL, now I want you to paste. And you should have this. Okay, so this is the URL. This is just the name of the directory that it's going to create. It's going to create a directory and put the files in there for Git. And then it's going to, it says create project a subdirectory of tilde. That's your home directory. Okay, that's your home file space. So don't change that either. Otherwise, we might have problems. Yeah.
Sorry.
Sure.
Where did we get that URL? That might have something I walked through later.
Yeah, I guess I can you just help with this? Yeah, thanks.
Thank you. Sorry.
Yeah, no problem. All right. Anybody else having any difficulty?
I have a quick question.
Yeah.
So when you put in the URL, the directory name.
It went straight in there. Yes, everything else got auto-populated. Oh, well, let me see what you got.
I changed the subdirectory. So I just pasted it in the URL.
And I didn't do anything?
No, but.
You're Premiere. Okay. Yeah, okay. Go to browse.
I'm gonna.
And then just go. Okay, good. That's fine.
It's right here.
So just choose. And then put a directory you want for the project. It should be this. Yes, copy that. Very good.
Okay. So R25 dash.
Oh my gosh, thank you.
Yeah. No worries.
So if any of you are students on the Premiere program, you might have already been in here and you might have some weird default on that screen. Can I get rid of this QR code now? Or?
Can you just, I'm so sorry.
That's okay, take your time.
Is that lab?
Yeah.
Sorry. My eyes are just.
Oh, just wait.
Awesome, perfect, thank you.
Okay, great. Okay, so where am I now? I'm here. Okay, so hopefully everyone is here. You have the URL for the GitLab. You have the project directory name, and you're going to create it as a subdirectory of home, which is represented by tilde. Okay. And now we say create project, and you see all this flash before your eyes, hopefully. Yeah.
It doesn't fall from me.
Come on over.
Are you a Premiere student? Oh, okay. Weird. Okay. Anybody on Zoom need help?
Janice, what was the project directory name?
The project directory name should be 2024 2025-HIV-workshop.
Thank you. Me.
I also got the fail error, and I texted.
It may not be, if you type in the short URL or the long URL.
I think the short one.
Yeah,
Oh, yeah, you can't do that, sorry. You need
Yeah.
the whole URL.
yeah.
So then, what,
Okay.
I copied from here, should I copy from?
Go to here, and then, right, and then copy and paste from here. You don't need this last part, just up to workshop.
Thank you very much.
Okay, how are we doing on Zoom, guys? Okay, no one's freaking out, good. Are you there? Pretty much. Oh, great. Okay, cool. All right. So now we have our studio container, and within that we have the course materials. So if you go over to the little file tab over here, you should see what I see here, right? You should see all these files right here. And we're going to go in and we're going to get the R Markdown file for this, and you're going to be able to see both. You're going to be able to see the R Markdown, and also we do something called knit, and it turns this file into an HTML file. Okay, so I keep picking up the mouse and it's not connected. Okay, so go to workshop 1, data science, and then to lectures, and then 01, day 1, introduction to R.RMD, and click on that file. Okay, and you will see, you should see this. And so this is R Markdown. What it is we call it literate programming. So basically you can have text, and in this case, Markdown text, or even full on HTML text that goes together with your code. So here's a bunch of text, space stuff. And then if I scroll down a little bit more, a lot more, there's a lot of text in here, you'll see that this is a code cell. So there are 2 different types of cells here. One is a markdown cell, so that's the white up here. So you can put text in there, and also like URLs like this. And then there are these other code chunks. And if it says R in the beginning, it's an R code chunk. You can actually have, I'll show you up here, you can have R, you can do Bash, D3, Python, RCCP, CPP, SQL, or Stan. So those are all different programming languages, and you can have cells for each of them in here. But we are really, as the scope of us, we are just going to stick with R chunks. Okay. All right. So I've written this lecture in R Markdown. I hope I haven't changed. Oh, that's what I have to show you too. Hold on. First of all, we'll see. What did I change? There we go. Okay. So whenever we go into, we bring you to a file from the repo, what you need to do is you need to make a copy of the file. What's the shortcut to make a copy? I always forget. Do you remember? Don't follow what I'm doing right now. It's nonsense. I don't know what happened here. I could have clicked on the wrong thing. Okay, here we go. All right, so I'll just use, I think this is it. No, that's not it. Okay. All right, anyway, just go into the file, and there should be, well, we'll just do save as. I know there's a shortcut for copying, but I can't remember. So save as, and go to like before the RMD. I mean, you can do this any way you want, but what I want to do is I want to rename this file, because this file name is tracked by Git. And you are not allowed to make changes to our GitLab. And if you try to pull, and we will be pulling more files again, you will get an error because this file will have changed locally on your computer, and it's not changed in the repository. Git will have a fit about that. So you can do _mine, _ your name, anything you want, but be consistent for yourself. And do this every time you open a file, and then we will work in that file, not in the repo named file. Make sense? One day maybe there'll be a workaround to that, but so far this is the only one we know. So I'm going to save that, and now you can see that up here in this tab, it has the new file name. So now I'm working in this thing, and if I go and pull from the repo, it won't complain that I've changed a file that's being tracked. Okay. All right. So I'm going to show you what this looks like. So we do this. We take all these chunks and all this weird looking gobbledygook, and we knit it. So I just clicked on that knit button up there. What? That's not right. Did something, I mean, I ran this like yesterday. So data. Cannot open the connection, but it should. I don't know. I mean, it's there. .data, there's the file. But it has a change date of today.
I mean, I moved some stuff over.
It's okay. Huh.
It's still there.
Yeah, I don't get it. Hold on. Let me just go down to the where. 172. It's being very helpful. It's telling me where the chunk is that it's failed on. So 177. It's in here. There we go. Okay, so this is what we're trying to do. And yeah. Next console. Sorry to be debugging on the spot here. Oh, was data, did you move that under lectures?
I don't think I moved data under lectures. I moved some other things under lectures.
Oh wait, yeah, no. So I think something definitely changed. Let me see. So I should be in. Wait, no, my home directory.
I moved the later lecture.
What I'm noticing is weird is that the home directory, the current directory in here says it's the workshop, not the repo directory, which it should.
Yeah, I'm not sure. I mean, when you read that, you see right there.
Like, look, so it's saying that my working directory is my home directory, but it should be the project directory.
You're in the project.
Yeah, that's why it should be my working directory.
Yeah. I don't know. I mean, if you get rid of the 2 dots, I guess. Wait, is it 2 dots for now? It should work.
No, because I'm in lecture under here.
Yes, but it's currently in your local environment. It's not there, right?
I've been doing this for many years. This doesn't make sense. All right, workshop 1 data science. And we had data and lectures. And it should think that because that's where I opened the file, that should be the default working directory.
Yeah, I'm not sure why.
Did anybody else get an error when they tried to knit?
It should come up to them in HTML.
Yeah, and that worked for you guys.
Yeah.
All right, something weird happened in my notebook. I don't know why. Okay, I'm going to kill this. I'm going to reopen the file. My save as, I put it in the wrong directory.
Oh.
I see. Okay, can we kill this? Delete. Yeah. Yes, I do want to delete that. Thank you very much. I'm going to go back here to lectures. I'm going to open the file again. And I'm going to say save as. And it really should have, yeah. So it should be saving in here. I don't know what I must have hit something wrong when I did that. Okay. All right. Now I'm gonna knit it. Well, that was fun. Okay. Oh, no,
Try again, yeah, it'll pop it up.
no, but I got a warning again that they couldn't find the file. All right, we'll see what happens later. Anyways, let's open this up. Okay, so this is the HTML. So this is the thing that it knit to. And oh, good. I was supposed to do this at the very beginning, but I'm going to do it now. I know. Well, there we go. Make the whole thing smaller.
For the people in the room, if you haven't signed in, that first sign in.
Yeah, so this is a sign-in link. If you're on Zoom, did we have them do it too? Okay. All right, so this is the attendance link. We have to do this. It's NIH wants us to report back, like how many people we admitted, how many people came, and all that stuff. So there we go. Looks like I have an error in my code. But, oh, that's why it's so, because, no, because I made a mistake. Yeah, I have a syntax error. Okay, and then at the end, you don't have to do this now. Just do the sign in now, but at the end, I'm going to pull up the second QR code, and that's for a survey. And this is critically important. Okay, we need to get feedback from you. It's another part of our reporting to the NIH. So, you know, I mean, you're not paying for this course, but NIH actually is. And so we need to justify where they're spending their money.
And then, yeah, but we'll come back at the end. And it'll make this, you know, it helps us improve.
It does, yes, of course. Yes, we definitely want this feedback. Yeah. Okay, so. All right, so I started with like, what is R, right? So there's something called base R, and that's just really the very basic stuff that like functions like mean would be in there, functions like print, any kind of like operator, like a plus, minus, whatever, that's all in base R, right? So you get all of that, but you don't get a lot of, like, well, we're going to do a lot of tidyverse later on in this workshop, and those packages have to be installed separately from the base R. What you are accessing right now is a container that has everything you need. All of the packages we need for this class are installed in the container. But if you were to do this on your own computer and you install base R, you're not going to be able to use tidyverse functions or tidyr functions or dplyr functions. You're going to need to install those packages as well. So I just wanted to point that out, and so it's basically it is a package of packages, right? Just like Python, really. Okay. Okay. So first, I want to start out with some basic programming concepts, and this applies to any language, not just R. And I give this in the introductory lecture because I assume that most people who are here don't actually know any programming language. So the first one is style. And style is, style can be, is basically a choice. Like you have your style of clothing that you wear, and that's what you do. Well, you can have a programming style as well. Usually, like if people working as data scientists work in a particular shop, and the shop will have style guidelines. And they'll say, you know, for the assignment operator, I want you to use equal. Whereas in R, we'll learn that in a little bit, there's a back arrow assignment operator as well. And then, or they might say, I want, you know, you should have a space after every comma, you know, and no spaces at the beginning and end of parentheses and stuff like that. So why is that important? It's important that your code looks a certain way because it keeps the bugs down. So if you are actually following, and easier to read, right? If you don't leave spaces after each comma and you give a function of like 15 arguments, it's really hard for the reader to parse out what each argument is. It's much easier if you give it a little bit of spacing and such. And when you write, say, a for loop or anything like an if else, where the scope of that command is, you know, from here to here, then you indent so that you can see, so that it's easy for the reader to pick out what is part of that if else statement versus like the rest of the code. And I provided you the style guide for Tidyverse. And so you can use that. Again, it's really choice for the most part. Like there are smart stylistic choices and not so smart, but for the most part, it is really choice. And the main thing is consistency. You don't want to, just kind of write in one way and then switch over to another one. I have that problem because I sometimes use camel cases. We won't talk about that, but I sometimes lose consistency when I'm using variable names, when I'm naming variables. So I try to be on top of that. Okay. And always comment. So this is a code chunk that's rendered. This is 8/4. The below should be 2. Okay, it's a nonsense comment for a nonsense thing, but you should be saying what your code is supposedly doing. So here's one. The below are equivalent ways of assigning variables. So, and we're going to do that variable assignment next, but the left arrow, there's a right arrow, actually a forward arrow in R, and I actually like the arrows. We'll talk about that later. And then there's equal sign. I do not use equal sign for assignment in R, but some people do. And I will say that, yeah, I like the back arrow best. So variable assignment. So we take a name, presumably one that hasn't been used already in our code, and we use this right arrow. And what this statement is saying is, I'm going to take 3 and I'm going to assign it the name. I'm going to assign to the name X. I'm going to assign the value 3. And the same thing here to the name Y. I'm assigning 5. So then if I assign to Z X times Y, it will be 15. And I should point out here that what's happening here is in R, if you just put a variable on a line by itself with no functions around it or anything, it interprets that as print. So this is equivalent to saying print parentheses Z close parentheses, just by putting Z at the end here. Any questions so far? Did I see some things in the chat? Did Fabiola get help? Good. Okay. All right. Good. Okay. So we'll be doing a bunch of variable assignment later to get practice with that. Oh, and we'll see. Actually, let's do this. Let's actually do this. So let's go back to the other screen that has the R code in it. Okay. And I'm going to scroll down. Okay. This is line 111. Okay. And what I'm going to do is and I ask you to do it too, follow along with me. Just type in, because you're also getting practice. Oops. So I'm in the console window. So I assign 3 to X. I assign Y to 5. Okay. And then I assign Z to X. That's X times Y. By the way, R is case sensitive, so make sure you put these all in lowercase and don't mess that up. Okay. And hit enter. And now I don't see anything because the variable, when I assign something to a variable, R doesn't mirror that back from me. So it won't print it. If I just did X times Y, R will just show me the value. But now it just stored the value in Z and didn't print it out. So I'm going to type Z, and I can see that that is 15. Okay. And then I want to see that's right. Note that here, if you go into the environment tab, up in the upper right quadrant, you can see that R is keeping track and RStudio is letting you know what's in the environment. So I've got X is 3, Y is 5, Z is 15. I also have a history tab, and that's all of the commands that I gave. This is useful if you're kind of like, when I develop code, I'll often just type into the console something and see what happens, like see if it works. And then if it does, I'll come and then you can do to console or to source. So if I do this, it will put it into the source code for me. I'm not going to do that now because I don't want to mess with my notebook. Okay. So, all right. I'm gonna go back to the HTML for a minute. Yeah.
Yeah, so in the console window, what is it that number one in the graphic, what does it mean?
Hold on.
In the output.
Oh, here, yes. That's the length of the variable, right? So it assumes numbers are vectors. So this is a one-dimensional vector, so that's the first element. I think if let me do something. Right, so this is just, our norm, we'll play with that some today, maybe, if we get to it. It just generated 10 samples from a normal distribution with mean 0 and standard deviation 1. And the one is, this is 1, 2, 3, 4, 5, and then this is starting at 6. Yeah. In modern programming, it's not really useful, in my opinion. There are so many other better ways to like figure out what's going on and to do that. But yeah, I think I do think that's kind of anachronism. Okay. All right, so I'm just going to go back over. I mean, I guess I can use visual, but I think what I don't like about visual is that it's still in a small space. So I prefer, still in that little window. So I actually prefer to go back over to the HTML for this lecture especially. Okay. So we now have assigned variables, and we just did a bunch of things that we just assigned a bunch of numbers. In fact, just integers to variables. But we need to talk about data types because there are different kinds of data types, obviously, that you can have. In the end, what we're going to be working with is essentially like an Excel spreadsheet, right? We're going to be working with a table, and it's going to have, you know, column headers, and each column is going to be you know, a particular field, and it's going to have values in it, and these are what types of values that you can have. I call these atomic types because they're the smallest thing that you can have. So there's like a numeric. This includes both decimal and floating, floating point and integers. And that's sort of the default type for numbers in R. If you know other programming languages, like C, for example, they very much distinguish between an integer and a floating point, and it could be like a floating point single or double, or right. So they keep even stricter track of the type. In R, though, with tidyverse, we also have integers, non-floating point. So these would be, you know, any integer, but not, you know, nothing with a decimal expansion. I guess, you know, in R, when they first developed it, for their purposes, it didn't matter. You know, numbers were numbers. Excuse me, I'm having a coughing fit. Yeah, but like they added on, you can cast something to be an integer using a command called as.integer. And that only will allow you to do integer operations. Excuse me. It's not terribly important for our discussion, but it is a difference that you can have numeric or integer. Excuse me. And then you can have a logical data type, so it's true or false. So that would often be like what a function would return if you said, you know, is this true? Like if you form a logical operator, you say, you know, is X 0? And then the return value would be true or false. So yes, it's 0, true. Sorry, true is 1 and false is 0. And then there's characters, and these are words and letters. But numbers can also be characters. If you put quotes around a number, it's a character. And if you're doing certain operations, you'll see an example later, you can your number that you think is a number can be coerced to being a string. And then your code will fail if you expect it to be a number. So that's something important to remember. And then there's a factor, and that is just something that has a finite number of values. So, you know, in statistics, what do you call them? Ordinal variables, or?
We have them ordered by the, some intrinsic value.
Oh, I guess, oh, that's ordinal. So basically, like, I don't know, what do you call it when you have, like, it's just factor? Is that,
Yeah, because it's categorical variable.
okay, yeah, because this is not ordinal, right? It's not ordered.
It is, yeah, a factor can
Yeah.
be ordered.
It can be, but this one, like, the example I'm giving is actually like, something like, a variable eye color that actually comes up in the Star Wars, example data set, which is kind of fun. They can be blue, brown, hazel, or green. That doesn't have an order to it, but it can only be those things, right? And that's helpful because you get warnings if you try to put in something that isn't that thing. Okay, well, so we have these initial things. These are atomic types, right, that I just described to you, and then you can start stringing them together to make bigger things. So one thing, the first one would be a vector, and that is a one-dimensional array with elements of one atomic type. So in a vector, you can't have a string and a number, right? It can be a vector of strings, it can be a vector of numbers, but you can't mix and match within that, okay? A list is like a vector, because you can have, like, I think of a vector, I think of something that has 1 entry, 2, 3, 4, 5, just a number of entries. Like I can list the number, I can number the entries or label the entries. For a list, it's just like a vector, but the elements can be anything, right? So list is really the most general data structure in R. You can have lists that have elements that are lists and vectors and matrices and, you know, file names and, you know, just all kinds of weird stuff. Pretty much package anything into a list. And then a more strict list is a data frame. And that's a two-dimensional array that allows columns to be different types, but all columns have to be the same length. And within a column, it has to be the same atomic type. So the columns are vectors, right? And then and they have to, and every column in the data frame has to have the same length as all the other columns. So that is your Excel spreadsheet, right? The simple Excel spreadsheet, not the one that has 5 million tabs and little graphs and okay. And then there's something called a tibble, which is a new version of the data frame. Okay, this is from Tidyverse. It really is the data frame that everybody should be using. It's just that you had so much R written using data frames and expecting a certain structure in the data frame that they couldn't get rid of it entirely. So they just went around and just said, I'm going to create a new thing and I'm going to call it a tibble. And it's going to behave like a data frame in some ways, but better. And so they call it a tibble. And it's really like, you just should think of tibble though, as just like, you know, 21st century data frame. Okay. So here's some examples. Let's go back to the R code for the examples. Thank you. Did I just click on the wrong thing? I did. Hold on. I can do it. Okay. That's going to be way down. Yeah. Okay, here we are. So I shouldn't be doing that. Number's not actually, no, number's not a reserved word. You can check that actually. Yeah, okay. So I'm going to take the string number, so the name number, so X, Y, and Z were variable names. Now this is a variable name called number. And I'm going to assign to it the value 1.9999. And then a logical example of a logical, this is something that is always true. So this is a variable always true. Oh, this was written by a TA and she used, well, it doesn't matter because I didn't even think, but she used equal signs. And 1 plus 2 equals 3. 1 plus 2. We'll talk about this later some more, but notice that you have to have 2 equal signs when you're comparing something. So if I say 1 plus 2 equal 3, then R will interpret that as, oh, are you asking me if 1 plus 2 equals 3, right? But if you leave out an equal sign, in this case, it'll probably give you a syntax error. But in other cases, you could actually you can end up with an assignment. So if this wasn't 1 + 2, but it was like X, so you want to ask if X is equal to 3, but you just write X = 3, then you're actually assigning the value 3 to X, not comparing. And it will always be true unless the assignment fails, which it doesn't, so it's always going to be true. It's a very, very common logic error in code. So always true is true. So that's just an example of a variable that is a logical variable. So that's the type is logical, and the value of this particular one is true. This other one is always false. And then characters, I am a string is 1, but the other one is 1.999 in quotes. So that is a string as far as R is concerned. You cannot add it to another number. You can't, yeah, so let's do this. So let's do character EX4 and assign the string 1.999. Okay, so remember number is 1.999. We do number plus, oh, and you can also use tab to find. So if I hit I tab this number, and then it tells me, oh, do you mean character or do you want your variable? And so I'm going to just hit enter and get that. There we go. So this error in number plus character X4, non-numeric argument applied to binary operator. And that's because this was not a number. Okay, and some examples then. So those are the examples of atomic types. And then we have some examples of different of vectors. So V assigned to 0.5, again, a number in R is a vector of length 1. So there's not a real distinction between the two. Another way to create vectors is to use the concatenate command, which is the C. Right? So C of 1, 2, 3, or you can use this shorthand 1:3. So let's actually type that in. So V, and we're going to assign C of 1, space 2, space 3, and our studio is very nice. It puts the other parentheses out there for me. And I'm going to hit enter and then print V and see what it looks like. And so it's the vector 1, 2, 3. Okay. But I also mentioned here that you can 1:3 is the same thing. So I'll play a little bit with a function called seek, which basically generates a sequence of numbers, and you tell it where to start, where to end, and what the increment is, or some combination of those things. And it's very powerful for generating sequences. So W concatenate a right, and then you can see. So the way you can tell if something is a number but it actually got coerced to be a character, you'll see it when you print it. It'll print it in quotes because characters and strings are always presented in quotes. Yeah, and let's do bad. So bad, I'm going to assign C. So this is the concatenate function. Concatenate returns vectors. So if I put 2 and 4 in there, see what happens. See what happened here? So I gave it a character 2 and a numeric 4, and I was like, oh, I'm sorry, you must mean character. And it will always default that, even if you give it mostly numbers and then one character, all your numbers will turn to characters. But you can do, so this is, you can see a list. Okay, that shouldn't be bad, actually. So let's do good. to list 2, 4, and print good. So lists are a little bit weird because they're not like vectors in that if you try to say, give me the first element of this vector, and it's a numeric vector, it's going to give you a number, right? If you say, give me the first element of this list, it's actually going to return a list, unless you do like a specific syntax to ask for the actual element. So it will give me back, if I ask for the first element, it'll say, the first element of the list is 2. So there'll be a list of size 1, not a number, or not a character, if that makes any sense. But here you can see that the 2 went into the first element of the list as a character, and then the 4 is a number. So this is how you can, this is a good way to be able to assign things. Oh, okay. So in the next example, I want to show you a named list. And so I need to create B because we didn't do that before, 0.5. So I'm going to create B. It doesn't matter what, just give it any numeric value. And then I'm going to create this list, L1, list of first equal B, second equal V, third equal W. And so what we get out of this is we get a list, but on the left hand of the equal signs here, first, second, third, those are the names of the list elements. So you can name the elements of your list, and then you can access those elements with the names. So you can see the first was B, which is 0.5, so that's a number. The second is 1, 2, 3, because that was what V was, and the third is ABC, because that's what W was.
I'm getting an error with the list,
Huh?
saying status code 503.
Oh, that's the container. That means that 503 it was just kind of like waiting, right?
I'm not sure.
I think it's just, yeah, just hit enter a couple times. Also,
Yeah. Maybe
it
even
should. Yeah, sometimes the containers, like, I think it's established connection with our server. So it's basically not, it's not, you're running the screen, but it's not connecting back to the server.
I just close out and come back in.
Usually, if you wait a minute, it comes back.
Yeah, if you click on the My Interactive Sessions part,
Yeah.
like where it lists, does it show that it was it?
Yeah, that's a good question. Yeah, on the, it looks like it's a community refreshment. Oh wait, does that say completed? Oh, relaunch, yes, click on relaunch. I don't know,
Oh, maybe it was just a short time.
maybe, did you change the wall time? Wall time should have been 4 hours, whatever, if that happens again, we should back out and just create a new one.
Okay.
But that's fine for now. Okay,
Thank you.
yeah, no problem. All right, so we've got this list, it's a named list, and you can, like I said, you can access elements of the list in different ways. So L1 $3rd is the one I have in the notes. So that actually gives me the content of that list. So it's returning to me a vector, the vector ABC. Right? If I want to show you something else, if I use the numeric and just one bracket, this is going to return to me a list. Yeah, see it says $3rd here and gives me this list. So this is not a vector as far as R is concerned. This is a list variable. And these, believe me, these do actually matter. And this is where you can get into really weird debugging. You kind of, and this is another thing that actually tidyverse, another problem that tidyverse solves pretty well. That was part of the reason that was one of the main motivating factors was to get rid of these, bug-inducing syntax that, people didn't understand. So it's tidyverse is very careful about saying what types it's going to return. Whether it's going to keep something as a tibble or it's going to turn it into a vector or something like that. Because how our functions work on these things is very different, right? So I just wanted to show you that it's not, and then if I wanted to get the other behavior, I could do L1 with 2 brackets, and then it returns me a vector. But again, this is base R, and we'll look at data. We'll be using dplyr and the select function and stuff like that later, and that's what I would hope that everyone would use. All right, let's see if I can actually. Okay, I'm just going to check my working directory real quick. Yeah, okay, did I do this again? If you guys type this in, what do you get? Get WD?
I guess the same thing.
You get the same thing.
Just as a, yeah.
All right. I don't know why this is happening. This is something I'm going to have to figure out on break, which probably should be having. Oh, no, it's only 2. Okay, another 15 minutes. So I'm going to just set the working directory. And if I do quotes and tilde and slash and then tab, it will show me my options. You guys should probably only have one thing there, or unless you have other stuff on DCC. I'm going to go to the workshop. I'm going to hit tab again. I'm going to say workshop data science. I'm going to tab again, and I'm going to put it in lectures. Okay. So I basically just tabbed it. Does anybody want to see that again? Okay. Go back again. Okay, so I'm using the command set WD for set working directory. This is a patch until I figure out what's going on. Okay. So quotes and then tilde, that's your home directory. And then hit a slash and then tab. And that will give you a list of things that are possible, or it will just put in one that the 2024 HIV if there's nothing else in your file space. Okay. So I got there. Now I'm in the top directory of the repository. I'm going to tab again, and then workshop 1 data science. Okay. Enter, and then tab again, and then down to whoops. Okay. Tab again, and then lectures. Okay, and I'm going to hit enter there. Okay, and now when I do that, I'm gonna now I should be able to access the file using this path. Okay, so LWHIV assign. So I'm going to assign it the output of this function read.csv. So read.csv is a function that reads in comma separated variable files. And you can also do delimiter, like you can use tab delimiter, tab as a delimiter or whatever you have, and there are functions to read any of these in. There's also functions in other packages to read in Excel files, and very fancy functions to do that. Okay, and so I'm gonna read.csv, and I'm gonna use quotes here, and then the file I want is // So it's // because it's in Unix, that's the syntax for go up a directory. So I want to go up a directory and then down to data, because I've got the workshop directory, workshop 1, and then underneath that I've got lectures and data. So I'm going back up to 1 and then down to data and tab, and this will give me like whatever I have in here. And I want this one, persons living with HIV/AIDS. Okay. Hit enter. Okay, cool. Okay, and now I can see that. So this is read.csv. Read.csv is base R. It's installed with R, and it's a very, very old code for reading in CSV files. I do not recommend you use it, especially if you use it on very large files, because it is read underscore CSV from tidyverse is like a 1,000 times faster. I think it really is like 1,000 times faster. But for this is a very small file, so it doesn't really make a difference. Living with HIV. So I'm going to use the function now head that says give me the head or the top of the file. So it's just going to show me the first like 6 rows or whatever of the data frame. And I don't see a lot here. This is actually a really funky file because it's basically the way it's done is it gives you the year, the age at the end of year, that's a category, right? And then the group is 0 to 11. So this particular page, in this particular category, ages 0 to 11, we had 164 people in this. Yes.
I remember saying all of the sections are here, executing here.
So I'm pretty sure it was defaulting to 4 hours on the thing, but all right. If anybody's having connecting, okay, the console is still. Jessica, did you get a response to that? Oh, great, thanks. Thank you, Jessica. Okay, yeah, and if anybody is having, it seems like some people are getting, having their containers aren't connecting anymore, and it turns out that their sessions expired. So if that happens to you, so you should go to My Interactive Sessions, and you should see, like here, I have 3 hours and 4 minutes left, time remaining. So if yours is like, says completed, or you know, there's like little time remaining, you might end up having a problem. So if that happens, you would get an option. If it actually times out, you'll get an option up here where it says running. Instead, it'll say relaunch. So just in case it's happening to a few people, I don't know. You should have on the when you created the session. So you can actually just go back and do that again, right? So if I went and tried to create a session, wall time here should be 4 hours, which would mean that you have 4 hours to keep it, and the container will keep going. But if for some reason you change that to 1, or you have used DCC before and there was a 1 in there by default, then you might have a problem.
And it's also being authenticated. There was a blip in the internet connect or something along those lines where it wasn't communicating.
Okay, yeah. That's another way to get that error. Yeah. Okay. So back to the file. So this is a file called Living with HIV, and I don't remember what cohort this was. I believe, I don't know, maybe it's in the U.S. People living with HIV. Well, so this is like the year in 2011. The category is age at year end. And that's the group is the 25 to 29, and then there are 6,351. It's some cohort of people living with HIV, and I don't know if it's like just the US or another country or whatever, but that's what this is. But you'll see it has, it's an odd, this is not a very tidy data frame in terms of what R would like to expect. But anyway, so we were using, read.csv. I gotta get out of this visual. It does not do anything for me. Okay. Whoops. Oh, brought me out of my thing. Okay. So that was read.csv. We need to load tidyverse in order to do this. Actually, what we need to, it's read R, right? That we need to load, but we'll just load all of tidyverse. I'm very lazy. Some people, when they use it, so tidyverse is a group of packages that all kind of work on the same principles. So when you install tidyverse or load tidyverse, you're getting a whole bunch of functions, just a whole bunch of packages here. So it's attaching dplyr, forecast, ggplot2, lubridate, per, readr, stringr, tibble, and tidyr. But you can also just load dplyr or tidyr, depending on what you're doing. people who are very, pay a lot of attention to detail, will probably do that. People like me, just hit the big button and just get everything. Okay, so, so we've loaded that, and now we can use this read underscore CSV file. So I'm gonna LWHIV underscore Tibble. So there are many differences between these functions, but one of the main ones is that read CSV returns a Tibble and not a data frame. So CSV tilde / tab, and then we'll do, oops. Okay, so we're going to do the same thing. So go and find that file again. Okay. And I was at enter. Oh, what did I do? Oh, no, that's not a problem. Okay, don't worry about that. Yeah, so it's telling me that 225 rows, there are 4 columns. The delimiter in the file was a comma. It's giving me a lot of this other information. And you see character, category, and group, and double for year and count. So here's where they're actually, in Tidyverse, actually keeping track of whether something is a double floating point or an integer. So this is, but although the thing is count is actually an integer, right? It's not, but it's just labeling as a double. So it's basically saying, oh, generic numeric, because I can have, you know, my integers are just like decimals with you know, zeros after the decimal point. Okay, so now let's have a look at this. Now remember with the read.csv, I use this head function, but for this one I actually don't need to. But I'll show you first Tibble. LWHIV. Okay, hold on. Did I? Huh. Oh, I didn't. I somehow got rid of the Tibble. So now it's just okay. And LWHIV. Okay. So now you see it's a Tibble. So it says right away it's the Tibble. There are, because I took the head, it's output the first 6 rows, so it's 6 by 4. And then it gives me this. But I can also just print this to HIV, and it will tell me it's 225 by 4, but it will only print the first 10 rows. And I can ask for more if I want to, but it actually gives me a nice print basically of the data frame. Because if I did the other one, it just scrolls. It just keeps going. It prints the entire 225 rows, and you just see everything wrapping, and you don't see anything useful. Okay. And so this last bit, we can do that. We don't actually have to do it, so I'm going to leave it. Okay, and now I've got exercises for you, and it is 2:15, well, 2:12. This is a good time for a break. Yeah, so slow. Okay, so go ahead and either, I guess we're going to go on break for, let's say, a 15-minute break, but then you can also do your exercises in that 15 minutes. So we'll come back at 2:30, but that should have enough time for exercises and stuff. Sound good? Okay.
Did everyone in the room sign in? Yes. Okay, cool.
And what are we supposed to type in following the grid and equals like that? Because I wanted to see more of those,
Oh,
like what those stuff.
I actually don't know. When I want to see, okay, there are a few things that I would do here. First of all, I'm only seeing the rows at the top. And actually in this particular file, it's better to see different runs. So I could use this is deprecated, but it's not going away anytime soon. So sample N, and I forget the default, I think, what? Can't compute, what?
Oh, yeah, I got the same.
That's odd. We still have tidyverse loaded. Okay. Okay, it's superseded, but oh, I didn't give it N. I guess it doesn't have a default. Yeah, it just doesn't have a default value for N. I thought it would have a default. So, so here I did 5, and you can see like there are different the different categories: age at year end, transmission category, female adolescent unknown, age. Yeah, so it's telling you what all their different categories are in this file. Yep. Okay. So there's not a whole lot of, I have a lot of stuff I want to go through, but I also just don't want to blast through things without you guys understanding what I said. So were there any questions on the exercises? Yeah.
I did for exercise number 4, I did print in parentheses liquid HIV, comma, N equals 15.
Hold on a second. Where is exercise 4? Did I? Did I not?
Oh, no, that was the one. I don't know why I have, something happened in number 2 that listed as 1, 3, 4.
Oh, okay.
That was my.
Oh, I think, no, I don't, I think it might be my fault. I just changed something in my code and reknitted, to fix the directory problem with the data file. Okay, so yeah, so which one?
Number 3.
Number 3, display the first 15 rows of the LWHIV data frame. Okay, yes, and the question is?
I did print parentheses liquid HIV, comma, N equals 15.
And does it work?
And it printed the entire thing.
Oh, that's interesting. So I think that should have worked, but that's not how I would do it. I use head, so head, and then you give it the data frame, and then you say N equals 15, and that works. Cool. All right. Any other questions? Any questions from Zoom? Okay, cool. I can provide solutions to these, but I don't want to take the time to go over every single exercise because, yeah.
I was wondering how do you add an element to it? Because for the number 3, I could L2 list of first, second, third. But is there ways to directly add a third element to?
Yeah, sure. You could, I believe concatenate will do it. So C should work. So do you mean you have, sorry, what I asked you to do was create these 2 and then, and then just create a list with all the 3, right? So yeah, so you're saying if you add 2 and then you added a third to it, yeah, you can do that. And I believe the best way would be with the C command, but I could be wrong about that. I would probably just use C. So you would say C list name, you would say C list name, and then comma, and then select the next variable that you want to put in it. That should work. You look skeptical. Can we talk about it after class? Cool. All right. Yeah. So let me move on. There's always so much tension between like trying to help everybody get through every single bit and then also like getting through the rest of the material. Okay. So those are the exercises. And now I'm back in the markdown for now, just to talk about these things, but we'll get back to them. So we have these, I've showed you all these data types. We've learned how to assign variables to values, and we learned how to make lists and things like that. So we have these things, we usually want to do something with them. And so that's where operators come in. The very basic operators are your arithmetic operators. So star is multiplication, plus is addition, slash is division. And I don't know where minus went. Minus went away. But that could have been, I don't know if it was something in the code or if I just left minus out, but of course that's another operator. And then there are logical operators. So remember, we have these logic data types. We can compare two variables in certain ways, and we'll return a value that is illogical. So we have greater than, less than, double equals for equals comparison. Exclamation point equals is not equals. So if this does not equal, that x is not equal to 0, for example. And then greater than or equal, less than or equal. And they all compare variables and return a logical. And then for logical variables, so I have something that is, so maybe I'll say x is less than 3. So that whole statement there, that returns a logical, right? And then if I want to say, and, x is greater than 0, right? X is less than 3, x is greater than 0. So I would use the ampersand. So that's the and, so that's logical operator for and. If I want or, it's the pipe symbol, this vertical line. Okay, and you can do really cool things with these. I don't have examples in here right now, but I think I have some later in the exercises. But you can like compare. You can look at a vector and look to see, like which values are greater than 0, for example. Like, so I've had a numeric variable, and I said, actually, let's just do that. Okay, so I'm just going to go ahead and create. So 10. So I just created a variable called x, and it is I assigned that to a normal sample of 10. So x looks like this, and then I can say x less than 0. And I get a logical vector back, which is kind of fun. Because then you can actually also like do cool things like if you sum these, it will make the trues 1s and the false 0s, and you'll get a number at the end, and that'll be the count of how many trues you had. That's something you see in a lot of our code. But anyway, so these operators operate not just on, and we'll see some examples of what I call vectorization, where we can do that. And then this is also an example of vectorization. Back HTML. Okay, so I'm going to point you towards getting help because in some of the exercises that I'm about to give you. So this is a part of the lecture where I have you doing a lot more. Getting help, you can, within R Studio and R, you can type the question mark command. So if you give, where is it? Yeah. So say question mark print, that will give you help on the print function. So if you know what if you know the function you need help on, you do that. So let me show you what that looks like. One thing that's really nice about R is this very, very consistent documentation. Okay, so here, so if I say question mark print, over here in the help window, it'll bring up the documentation for print. And it's kind of a bad example because this is something called a generic function. I don't want to get into that, what that means. Basically, it means that when you execute the function print, it looks to see what is it that you're printing. Are you printing a vector? Are you printing a data frame? Are you printing a tibble? And it has different functions depending on what it is that you're trying to print. So that's all that means. But anyway, so that's how you can get help there. And there's also, I think you can do, there's also apropos. So using apropos means you want functions that kind of have that word in it, you know, or have that as, you know, something that has to do with read. And you'll get a bunch of options there. And then the other thing you can do, oh, I did not say that there, did I? I'm wondering if I got something out of order here. Yes. So this is, you know, how you can get help within RStudio. But also, I mean, honestly, most of the time, sometimes I'll just go check the documentation, but honestly, most of the time I'm looking for something that I need to do in R. I go to Google and I say, Google, help me. Also, I mean, now we've got Copilot. I mean, I haven't even really begun to use AI, but that's always an option. The only thing is I would say, maybe I'm old-fashioned at this point, you should understand everything you're doing, everything you put in your code. You know, don't just like go to Copilot, ask it to write you a function, and then cut and paste that in and just, you know, assume that it's right, because it's often not. And also, yeah, you want to know what the code is doing. Because you want to debug it at some point. What?
It can give you incorrect answers of coding.
It can, and also, like, if you don't understand what your function does, it could be that it hits some kind of input that you weren't expecting, and then you get an error and you don't understand it, and it's really hard to debug if you don't understand what the function was doing, and you know what the individual lines of code were doing anyway in the first place. Okay, so this is just a little bit of exercise in yeah, this is parsed incorrectly. So using arithmetic operators on numbers is what we're doing. Oh no, okay, no, it is right. Okay, so number one. So I'm giving you an example. So an HIV infection, modeling an early infection is pretty complicated, requiring systems of differential equations. But when a patient is put on ART from, say they're at some peak viral load, you can measure their viral load as ART starts decreasing, right? As the viral replication goes down, the viral population in the blood goes down, and it's a nice like exponential, but it's not exactly an exponential. It's actually usually a sum of exponentials fits the data better. So that's what this is. This is a sum. So this is V of t is equal to this constant A times e to the minus delta times t plus b e to the minus mu t. Okay, so what I want you to do is let A equal 100,000, B equal 20,000, delta equals 0.05, mu is equal to 0.025. And I want you to find the viral load at time t. And so e to the x is the exponential function, and in R, and in any programming language, exactly, it is x of x. It's not, you don't do e to the x because it's, yeah, unless I have the number e defined, that won't work. So it's x of x. And note that when we write down functions, we don't put the multiplication operator in, right? So this is a times x of minus delta times t, right? So make sure you put those operators in. Let's see what you get. And then number two, write the formula in part one. Yeah, so here basically I want you to, so here I just want you to compute a number, right? And then in here, I want you to actually define variables, A, B, delta, mu, and t, and then assign those values to those variables, and then compute using the variables. Okay. And you should get the same answer. think I'm gonna skip 4. So let's skip 4, just do the first 3. Sorry, I'm rereading this. Just do 1 and 2, because 3 and 4, it's silly to do 3 without doing 4, so we'll just skip both of those. How many of you here in the room are finished? Still getting, okay, and you're done. Okay, thank you. And I'm sorry, I should have learned your name. Refresh yourself.
1 and 2.
Yeah. Yeah, okay. Is it, now that everybody has a computer in front of them, right? Like everybody's sort of doing it, you finish, and then you do other stuff, and it's hard to like know when everybody's done. Okay. Yeah, so. Oh, he's got a backslash. Get rid of the backslash on the dollar. That again, that was latex.
You're right, thank you.
And what is latex?
Oh, it's a typesetting language people use for typesetting mathematics. And so like backslash delta gives you a nice pretty delta.
Oh.
That sort of stuff. Yeah. But it's like a markup language for math. It was originally, and you know, people debate this, whether it's LaTeX or LaTeX. But I say it's LaTeX, and the reason it's LaTeX is because the reason they called it LaTeX is because the first typesetting code was called TeX by Donald Knuth, and it was very, very, very involved. Like so, like typesetters could use it, but mathematicians were not typesetters. So layman's text.
A lot of the latex commands, you know, like you'll get them in Windows. You got the Windows equation editor.
Oh yeah.
Yeah.
Yeah, I think they adopted it now, which is much nicer than what they had before. Okay, so it looks like only 6 people raised their hands on Zoom. Can I help anyone? Okay, well then I think I'm just gonna, I just did 2 because 1 is really it's just sort of a warm up to get into 2. So here we go. Here we go. All right, so a little code chunk. Okay, so here's the number 2, basically. So I define the variable A, 100,000, B is 20,000, delta is 0.05, mu is 0.025, and T is 3. And then I just write the equation down in R, not in LaTeX. So it's A times exponential of minus delta times T plus B times exponential minus mu times T. And for some of you, this may be like exceedingly simple, and I apologize for that, but this was the introductory course. And we often do have people who have a lot of trouble just getting that down. Okay, so V sub T is that. We're not gonna do this other stuff. Let's go back to the HTML so I can see the pretty part. Okay, yeah, so that was that. So just using just a little bit of an example of using arithmetic operators for people who've never done that before, because if you've never done it before, it can be really confusing. And it's gonna be really hard to write other code. Okay, so loops and branching. So I am branching, I'm actually not going to talk about this part, but branching is when you use like if-else statements, so that your code means your code is going along, and then there's a decision point, right? Is this true? Oh, if it's true, do this. If it's not, then do that. So that's called a branch. We're not going to really get into that, but I don't know. I kind of think if-else statements are pretty self-explanatory, but if they're not, ask me. But loops, now we almost always want to repeat things. That's why we're using a computer. That's why we're writing code, right? Because we want to do it more than once. So I'm going to teach you for loops. How many people, again, okay, please on Zoom and within the class, know how to write a for loop? Yes. So if you really do, just raise your hand so I can, I know if you already know how to, you're like, well, of course I know how to write a for loop, but there are actually people in here who probably don't. So no, right, yeah. Okay. So people on Zoom, how many of you know how to write a for loop? How many of you are still awake? Not sure which question he was answering. Okay, that's actually not that many hands raised. Okay, cool. All right. All right, so I'm gonna teach for loops, and I'm gonna use a very stupid example that you would never ever do in R. I'm gonna take a vector and I'm gonna double it. I'm gonna double the elements one at a time. That is not how you do it in R, but it's just a simple example to show you how to iterate over something. So the first thing I have here is I'm creating the vector v using the seek function, which creates a vector of numbers, and you can give it the starting value, an ending value, and an increment. So this is going to start at 2, and then it's going to add 3 until it gets to 20. And if it was like, if the last one was like 21 to the 20, it would just stop at 17. So, but you can also do from 2 to 20, and then say length equals something, and then it will figure out like what their increment has to be. So you can do it either way. And this is useful. I use seek like a lot. Okay, so I'm going to give you the first a breakdown of what the for is. So the syntax here is I'm saying for, and then there's within the parentheses is the sort of like telling, is the command, is saying how the for loop should go. So I is my iterator variable. So each time first time I go into the for loop, it's going to initialize at the value given by this list. So 1 colon length of v. So I should also mention for people that don't know, v of 1, v open bracket, close bracket of 1 is the first element of v, and of 2 is the second and third and so on. So I create this, so 1 colon length of v is the consecutive sequence starting at 1 and going to the length of v. So it's 1, 2, 3, 4, 5, and however long v was, I don't remember. Is it 1, 2, 3, 4, 5, 6, 7? Okay. So it goes from 1 to 7, and it's right in front of me, because I'm printing I each time I do it. So so when I goes into the first one, it takes the value 1, and then it does what I say in the body of the loop. So print 1, take v of 1, and assign it 2 times v of 1. So double that element, and then it goes down the second time. And it goes over to this list, and it says, what's the next element in my list? It's 2. So now I'm going to print 2 and take the second element of v and double it, and so on. Okay, I'm going to do that overall. And then you can see if I print the value of v, because I overwrote what the elements of v were, now v is doubled, and I can see that I've got these values instead. Okay. Any questions on that? Okay, all right. So the I is an iterator, as I said, and this just describes like what I just said out loud, so I'm not gonna go through it again. But I want to show you that this is much more general than that. You don't have to have a list of consecutive numbers in R. Like in C, you do. That's how a for loop works. You give it, I is an integer, and it's going to be, starting from 0 and going up to the length of array minus 1. But in R, iterate a list can be any list, really. So here I can just give it a bunch of numbers, so 1, 10, 32, 1.5, and then I say for I in this list, print I. So what it does is it goes into the iterated list, first element. What's the first element? It's 1. Okay, I want to print that. So I will take the value of each of these consecutive iterations of the loop. So in the first one, it takes the first I is 1, second one I is 2, I is 32, I is 1.45. Okay. I can, like I said, I can iterate over any list. So here's a list that has a bunch of numbers and then a couple of strings, and I do the same thing. Say for I in this list, print I, and I get all of this result. So it's actually, I find it's really nice that you can do this because it's, I don't know, I grew up as a C programmer. So this kind of stuff is kind of magic. Okay, so I'm going to ask you to go ahead and write a for loop. I write a for loop to print out whether each count in LWHIV is less than 100. Do people want more time, or should I just go over the answer? Go over it. Just go over it. Anybody want more time? Scream at me. Okay, cool. All right, so there's definitely more than one way to do this, and there might be even more than 2 or 3. So the way that I did it was I used this iterator variable I, and I iterated over the list LWHIV $count. And so I gets the value, the first count in the data set, and then the second, and then the third, and each time it goes through each iteration of I ask, is I less than 100? Print yes, else print no. And then run it, and by the way, if you run this little, you can actually run the code chunk by clicking on this little green arrow here, and then it shows so this is in the notebook now, not in the console. Yeah, so that's it. Are there any questions on that? Code up there. Okay, then moving on. That was just a simple example of a for loop. And you do use for loops, but in R, where am I? Go back. Yeah, in R, you actually usually don't want to use a for loop if you can avoid it. And historically, it was because for loops were slow. But nowadays, in modern R, it's not really a problem. It's a question of speed. It's more a question of writing more code than you need to. And every time you type another character, it's an opportunity for a bug. So you can do things a lot more concisely without for loops. This course, we do not get into the apply functions or how do you say per? Is it per or is it per R or it's per with another? So it's PU and 3 R's. I never know how to pronounce it, but that's the tidyverse version of what's called lapply and sapply, and these are ways of just applying a function over a list. Instead of doing a for loop, you just have this list and you say do this function over this, and the per are the new ways. But so usually you want to not use a for loop, and if you find yourself using a for loop, it's not terrible. I mean, and honestly, like when you're developing code and you're starting to write something for the first time, it's the only way that comes to you in the beginning is a for loop. You use a for loop, and then later when you go back and you're refining things, then you can see, well, maybe I could use one of the per functions or something like that to do this. What I like about those kinds of functions is that you can do parallelization really easily with those, because you're basically saying apply this function to each element of this list, and so you can say for each one of those, farm that out to a different CPU. So, they are powerful, and if you're a little bit more advanced, you should look into those. Okay, so vectorization, I'm going to create the same vector v, just this random from 2 to 20 by 3, and then I get this vector, and then if I want to double v, I just do 2 times v. Now, of course, this doesn't change v, right? I'm just printing out 2 times v. But if I wanted to double v and save it back, I would do v and assign that to 2 times v, right? But yeah, so it's as simple as that. And many operations are sort of like, what makes sense, right? So, so if we have 2 vectors of the same length, right? And I use the multiply operator. What R does is it says, oh, I've got 2 vectors, same length. I am going to multiply them component-wise. So it takes v and w, so 2 times 1, 2, and 5 times 4 is 20, 8 times 7 is 56, and so on. So, so it does this component-wise. And you have a lot, and I think, I want to see if I actually, this is kind of a fun exercise, but I don't know if I should leave it. All right, let's do exercises 1, 2, 3. I don't think they should take very long. Yeah, so I'm saying create the vector using the seek command, but can you get the same results with a different syntax? So hint, earlier in the lecture, I pointed out a very cool shorthand for generating consecutive numbers. Then add 2 to every element of the vector and square every element of the vector. Everybody done? Those are pretty straightforward, I think. Does anybody have a question about those? Or I'm just going to skip going over them. So for the square, by the way, I don't know if you noticed, so you can either do v times v, that works, but I would do v caret 2, so like v raised to, v squared, because if you want to do like v cubed, for example, that v times v is fine for v squared, but if you want to do any power, then you want to probably use a more general syntax. Okay. So I'm calling these vectorized operations, and I'm a little skeptical. I mean, there really are, most of the ones I'm talking about are really kind of summary operations, but they take the whole vector, crunch it up, and punch out a number for you. So, in other words, like if I wanted to add the elements of a vector and I was programming in C, I'd have to write a for loop and go through and add them together. But in R, you just say, here's the vector, and you say sum v, and it gives you the sum. And same thing for the mean. I am going to, I guess I think I edited this and took out some things out of here that maybe it doesn't make as much sense as it used to, because I had people ask people to find other operations in R that might be like these kind of summary operators, but we're skipping that. So I should probably just take this part out. But this exercise is to see what happens, because there are a little bit weird behaviors when you try to add or multiply vectors that are of different lengths. So I'm going to give you this to try. So create 2 vectors of length 3. What happens when you add them using plus? I think we can guess what that happens, but create a 3rd vector of length 2. What happens if you try to add that vector to one of the others? And then create a vector of length 4 and add a vector of length 2. And so do all these things and see. Oh, I did actually keep this. Okay. We have example sum mean summary. Can you find some others? You don't bother with number 4 in the interest of time, but I do think one that, like, especially like 2 and 3 are important. Okay, so let's go over this one. This is something, I think you call it broadcasting in Python. I don't know if they call it, but what happens here, so let's see what happens here. So I've got a vector of length 3, another vector of length 3, vector of length 2. Oh wait, this one's supposed to be 4 actually. Let's see, 12, 13, and let's do 14, 15. Okay. My computer is not doing, there we go. Okay, so let's say we try to add u, a vector of length 3, to w, a vector of length 4. Is that what I tried to do actually? Let me just see. Add a vector of length 2. Oh, third vector of length 3. What happens if you, sorry, 2, what happens if I try to add that vector? Okay, so the third vector should be length 2. Not 4. No, I was right. Okay, so z should be length 4, right? Yeah, okay. Okay, so if we try to add, I'm going to get all these to work too. Okay, so now I ran those, and now I can say, now if I try to add u to w, so u has length 3, w has length 2, and let's see what happens. So I get a warning message, right? But it's not an error. It's saying, okay, you want to do that, that's fine. And what I'm going to do then is it returns, so it says, here's u and here's w. So at first it tries to do component-wise stuff. So it takes 1 and adds it to 10. It takes 2 and adds it to 11, and I get 13. And then it's like, oh, but I'm out. So what does it do? It goes back and starts at the beginning again. And so it gives me, so then it adds 1 to 10, and I get 13. That's the third element of the vector. Okay. So what it's doing is it's trying to, it's like, okay, I take the shorter one and I'll just kind of try to match it up as best as possible, right? So now if I take the vector, if I take the vector of length 4 and I add it to length 2, so that's going to be w plus z. It's fine. I don't get a warning. I get nothing. It's completely happy. It's just saying, okay, it's 2, so I'm going to add 10 to 14, 11 to 15, and then I'll add 10 to 16, and 11 to 17. And that's what it does. So I like to show these because I think they used to give errors back in the day. They didn't do this. I think to my recollection, I think this changed at some point when I was writing code in R. And it used to be errors, and then it stopped doing that. Yeah. Which I guess it's okay, but I mean, I don't like it because I feel like it's doing some kind of behavior that's under the scenes that I know. It feels like for me, I could end up with bugs that were unnecessary, but you know, I'm not in charge, so. Anyway, so you can see, so basically I just wanted you to see that it's going to do that so that, and you won't get even any message at all if it turns out that one is a multiple of the other length. One length is a multiple of the other length, and it'll just smash it up. Okay, so any questions on anything, really? Everybody good to go on? Okay, yeah, we probably should only go for like another, what, 15 minutes or so, and then we have to do the, yeah, one of these times to do the survey for everybody. So
You'll upload the answer, like the code answer.
yes, yes. All right. So yeah. So then next and final topic is functions. But it's, yeah, okay. I don't have a lot of time to do this, so I'm going to go through it. And yeah, we'll just see what happens. So you've already seen functions, right? You've seen seek, you've seen library when we loaded tidyverse, you've seen ext when we did, you know, the exponential sums. So R, basically everything you do in R is a function. even parentheses are functions actually. Plus is a function. So anything that's actually done involves functions. And so you can use the functions that are there, the functions and packages, but sometimes you might want to write a function of your own. And so that's not hard to do. I can give you the structure of a function. So basically, I should tell you, what is a function? So it's basically functions like in math, right? Remember you had f of x, and then so x was input to f, and then you got an output. So a function is a thing that takes an input, a set of inputs, and returns a set of outputs. So it does something in between, who knows what, and then it puts it out. So so the syntax for creating a function in R is you name the function. So this is when you make this up, and then there's this arrow, so you assign to this name function. So this function itself is a function that creates functions, if that makes any sense. What it is, I promise. So the function, so there's a keyword function, which is, the creator. And you give that arguments, like the things that are your inputs. So the arguments are your inputs that you want to give to the function. The body of the function does something, presumably with those arguments, or why would you be passing them in the first place? And then it returns the result. Return is a keyword to come out of the function, but generally you don't use it when, you only use it when if you're saying, if, something happens, get out, right? Not like you have a condition where you want to get out of the function early. Otherwise, you just, you omit this and you just put result, like you would be printing it, and then that's the output of the function. Okay. So like the mean function might, it looks a little bit more complicated than this too, because I'm going to check for lots of things, but a very simple mean function would look like this. Mean, take a vector, and then return the sum of the vector divided by the length of the vector, right? Or you don't even have to. Oh, right, I'm just saying normally. So you would not use the return here. That's just, so here's an example where I'm saying, okay, I'm not going to return. I'm just going to assign m to this value and then print m like that. And that's the same as return m. Okay. So again, I just said this, but I'll say it again. The function name is defined by u, but it's a really good idea to make it meaningful. Say what the function does. Function is a keyword. Arguments are the inputs. Body of the function are a list of R commands, whatever you want to do. Return is a keyword, which you're not going to use unless you need to exit the function early. And the result is whatever you want to send back. So simple example here. This is just completely randomly made up by me. I'm creating a function called myfunc, and it will have inputs A and B. And then I have a redundant line. This actually doesn't do anything because I'm making C, assigning A times B to C, and that's not going to do anything. But then I'm computing D to be A plus 2 times B and returning B. And then you can see if I call, so this is important, and sometimes beginners don't quite get this. If I execute this code right here without the bottom part, so if I execute up to this curly bracket part here, all I have done is define the function. This is the line that executes the function and gets the return value. So all I've done if I execute this block of code is I've told R that I have a function and this is what it does. But I haven't actually performed the function. Here's the function call itself. So I'm calling, and the argument A is going to be 2, and B is going to be 4. And I just put the redundant line in there to remind me and to tell you that when you call a function and you define variables in that function, once you exit the function, they go away. So they're not in the environment in R at all. A function has its own little little cozy environment and the cold rain and weather can't get in, and whatever's in there, just, it puts something out, but that's it. All the rest of the stuff in there goes away. So this really does absolutely nothing.
What would happen if you tried to use concat within that function after every time? If you tried to use C?
Oh, yes, that's a very good point. If I tried to use C, it would error because it's not the C function anymore. I've overwritten it, I believe.
I think
Yeah.
Could you write it in by adding return D comma D, and then it would rerun that function, then it would run it?
If I return C and D,
Yeah.
then I would get C back. Well, basically what I have to do is I have to return it as a list,
Oh, okay.
right? So I can only return one thing. So it could be a data frame, it could be a vector, it could be, but it has to be one thing. So, and then most generally a list. And yeah, Richard is right. If I tried to use concatenate in here, which is what you do sometimes when you want, concatenate is an easy way of, if you're just going to return a vector of two things or whatever, concatenate would be great. But it's true, I probably have in this function overwritten the C function. Yeah. I try to be careful about those things, but yeah, I wasn't thinking. Okay. Yeah, we'll probably see. No, I don't know. It might actually, because C is not a function here. So if I use the C function, it might actually know what I mean. Yeah. We have to just try it. I don't want to do it now because we don't have a lot of time, but I'll put that in the back of your. Yeah. Okay. This is good in what you said about T, right? So I'd like to know, because I everything I do is time dependent. So, okay. So now I want to just show you a couple of things. So if so the way that this works is, when I call a function, if I don't, so I have called the function, I've got A and B. Okay, these are the names of the function, right? And the names of the inputs. So here it's positional, right? If I don't tell R what I'm doing, it says, oh, okay, the first one is A, the second one is B, right? And I get this result. However, I can actually get the same result by using the names of the arguments. So B equals 4 and A equals 5. I'm explicitly telling R which arguments I want to be what value. So it doesn't matter that this one is first and this one is second. The default behavior is to take if I give it names, to use the names. Okay. Yeah, and I'm just showing here that if you do 4, 5 instead of B equal 4, A equal 5, then you'll get a different number. Because this one is doing positional, and so in this case, A is 4 and B is 5. So that's just kind of a, okay. And then I have an exercise. Should we do the exercise? Yeah, why not? Have most of you written functions on your own before? Yes, no? You've written functions before. Oh, okay, cool. Okay. Then, do the exercise if you want. Don't do it if you don't want. And then I'll just conclude here. I have a little something about packages and libraries. So what I was saying earlier, if you just install base R onto your computer, and then you want to use, say, there's a function called sample n from dplyr, which is apparently at end of life, but I don't care, I like it. If you try to use it without the library loaded, it's not in base R, so you will get an error. So I actually had to comment this out because I can't knit the knit will fail if I tried to actually knit the notebook with this line in. So I would have to call dplyr, which is the package that has sample n, and then I can use it. And what sample n does, I told somebody about this before. I really like this command because it randomly chooses names. It chooses rows. So so this is a bunch of, I got 10 rows from this from the LWHIV, but they're random. So in the beginning, everything was category was at year end. Remember when we looked at this file in the beginning? It was all at year end, and we didn't, age at year end. And we didn't see that there are other categories like race and ethnicity and age, current gender and transmission categories and stuff like that. So there's ways in Tidy, and you wouldn't do that if you really want to know what the values, distinct values of category are. There's a command that you would use in dplyr to find that out. But I like sort of like sampling rather than just looking at the top of a data frame, because you get a better idea of what's going on there overall. And often like mistakes happen kind of in the middle if people are entering things manually and stuff. Okay. And so just to make sure everybody understands this, there is a difference between the library loads a package for you, but you can't load the package unless it's first installed on your system. Okay, so I was able to load dplyr because it's installed in the container. But if you just installed base R, you would still have a problem even if you tried to load the library. It would say you don't have that. It would say that's not installed. So then you would have to use install packages and to install it. So you can find out what packages are installed by using installed packages. I use the head command because there are a lot of packages installed. I didn't want to see them all. But you can see this is like the beginning. You can see that there are a lot of them. Install new packages using install packages. I commented these out because I didn't really want to do this. So this is the syntax for installing and removing. And you can also see the installed packages on RStudio on the right. Show you that. Yeah. So in the bottom quadrant, you've got files, plots, and packages. So this quadrant will show you what's installed. So all of these packages are installed on my system, and then the ones that are loaded have a check mark. So base is there. dplyr and stuff in here too, right? I think. There we go. Data sets is installed. Not installed, sorry. It's loaded into memory. So basically what it does is like you don't want to install packages on your computer that you don't use because that takes up space. And you don't want to load packages into memory that you aren't using because that takes up memory on your system. So to be like as lean as possible, you should install only the packages you need, and then for any given application, only load the libraries that you're using at the time. Okay. All right, and I can't believe I got through all that.
I think ours throws an error if you try to load more than 100 packages.
Oh, well, because you had like 2 megabytes of RAM. Okay. I'm thinking about working with data frames, but that's not really. Oh, I just wanted to mention that there are built-in data sets to R that are for practice, and there are tons of them, and we'll see some in our examples later on. MT cars is a database with a bunch of car-like data. So the Mazda RX-4, what is its miles per gallon, how many cylinders, what's the displacement, horsepower, DRAT, I forget what that means. The weight, I don't remember what cubic means. How many gears, how many carburetors? Anyways, so it's a database about cars, and then there's the IRIS data set, which is for different species of, they have like samples from different species of, and they've taken the sepal length, sepal width, paddle length, and paddle width, and measured them. And then to see a list of everything that's available, you can just use this function data. So you get data, no arguments, and it does that. It will show you everything, every data set that is on your system to be used. Okay, and I have to make this smaller. I have to fix my code at some point. All right, so everybody did attendance, right? I need to put that up. Oop, come on. Oh, that's as far as it goes, because it's the end of the file. Okay, so the one at the bottom, the QR code at the bottom should link you to Qualtrics survey, or you can just use the HTTP